This session is very interesting. We have been doing sessions around AI agents for quite some time. And this session basically sort of, we thought, a lot of people ask us, what are AI agents? They're new to the concept. They don't know what AI agents are. How can they, use them in the enterprises or in their, personal life? How they can, build them. So we thought, let's do this session. Let's do a session on just on AI agents. And this session basically designed just for that. It's around AI agents. We are doing some incredible work in AI agents. So what I would also do is touch upon some of the things that we are doing, so that you get exposed to tools and toolings that we are building in the AI agent space for enterprises. So with that, let me start very quickly on with my slide here. Yeah. 2025 is the agentic AI year. I mean, it's not that I'm telling this. It's almost every CEO of a large tech company, from Google CEO to Meta CEO, or OpenAI CEO, Microsoft CEO, everyone is saying 2025 is agentic AI year. I don't know if you guys noticed, but OpenAI announced Operator agent just yesterday, where you can actually use this Operator AI agent to do multiple of things, including booking your Uber to booking your hotels and those kind of stuff, where the computer, basically the agent takes over your laptop or your desktop, your screen basically, and does as if the human is doing kind of stuff. So it's an incredible start to that. What people are saying that the 2025 is agentic AI year. And we actually are very excited about this, because we have seen in last, we have been working on the agentic AI for last more than 9 months now. Actually, last year we dedicated it to agentic AI, and we're realizing that we actually were in the right path, because agentic AI is just full force right now. So it's very, very important for all of you to understand. If you're new to agentic AI, it's fine. I'll basically cover a lot of basics, so you don't have to worry about if you're new to agentic AI. If you are well versed about agentic AI, I'm quite sure you will learn something new. And feel free to add, to the topic. If you have some inputs, you can just raise your arm, and I'll just unmute you, kind of stuff. So feel free to do that. And I just want this to be interactive. Feel free to ask any questions, kind of stuff, right? So 2025 is agentic AI year. That's something is I wanted to start with. Now, what we are building is something in that direction, which is Groclake. Now, Groclake is basically an agentic workforce infrastructure, which means that in an enterprise, any enterprise you may have, if you want AI agents as a workforce, as your digital team, as your team which works to, in a automation, like if you want to do a lot of workflow automation kind of stuff, right? So if you're building that kind of team in your enterprise, we basically are providing infrastructure so that you can build, you can deploy, and you can monitor, right? So basically you can do these three things as if you are hiring human employees. So you can basically build or hire digital employees. Then you basically deploy, basically put them in the office, and put in a collaborative environment. Similarly, you can deploy AI agents, and then you monitor, right, your human employees. Similarly, you can monitor your digital employees, which are these AI agents. So we provide the whole infrastructure, whole 9 yards, so that you can do that. And that's something is we are building very passionately, kind of stuff. So let me get to this topic, like what is an AI agent? And that's basically is a lot of people ask us. And fundamentally you can think of that AI agent is a digital human assistant. It's an assistant. Basically it takes an input, which can be a task. It gets a task, and it finishes the task. That fundamentally is broadly what an AI agent is. But it's digital, right? That is the difference here. It is like human, but digital. And that's fundamentally is something I'm going to take forward and compare a lot of times how AI agent is doing things and how human is doing things, and what are the parallels between these two kind of stuff, right? So that's something I thought I'll start with that, with a very simple definition of what is an AI agent kind of stuff, right? Now think of in the real life, right? In real life, basically, let's say you have a butler, who basically whom you interact primarily, right? You're interacting primarily with butler. You have a butler in your home, like in your house, and you're primarily interacting with butler. The butler works with like multiple housemaids and gardener and cooks in the behind the scene kind of stuff, right? So what you're telling the butler is a very specific task. Let's say, please cut lawn grass. My lawn has a lot of grass, so please cut that grass. Is something that you will tell the butler, which in the context of the AI, which also talk about is the orchestrator part. Basically, it's orchestrating. It is controlling the flow. An orchestrator is something that you will hear a lot in agentic AI. Almost, almost like if you look at any system, if you look at any provider who is providing agentic AI tools and infrastructure, they will have orchestration layer. Like, so orchestration is a very important part of it. Fundamentally, it means that this orchestrator is controlling the flow of tasks and making sure the task is completed kind of stuff, right? So that basically the orchestrator here. In this context, the butler is the orchestrator, right? I'm taking a real life example so that you can look at it when I'm talking about an enterprise setting. What is orchestrator is kind of stuff, right? So please cut long. That's a very specific task. So it's a single task, and the orchestration is very simple for the butler. Give it to the gardener, right? That basically is how the butler is working. Like, I'm taking this task from a master, and I will assign it to the gardener, which basically in this kind of stuff, right? So this is this very single task orchestration, very simple kind of stuff. But usually in life, we have seen that we don't really give simple tasks. We also give like a sort of a multitask kind of where we tell the butler that guests are coming. Please take care of guests with utmost care, right? Please make sure the guests are happy, right? That's the kind of things that you will tell a butler. The guests are coming, please make sure. Now, butler then needs to think, okay, for all these things, I need to plan. That's basically now the planning part comes. Like, it's not like single task. I just routed the task from my master to the gardener, right? Now I have to think, okay, what do I need to cook? When do I need to cook? Then how will the house get cleaned? And the garden has to be super good, because the breakfast will be served in the garden kind of stuff, right? So butler has to start thinking, and then he has to create multiple tasks, right? And then assign those tasks and make sure the tasks are getting completed in a collaborative way, right? And also monitor, right, that the cook has cooked the food on that time and those kind of stuff. So that basically is a multitask, orchestration, which with planning that the butler has to do kind of stuff, right? So that's like the next level, where a lot of collaboration happens, a lot of communication happens, a lot of planning happens, some kind of reflection and reasoning, which I'll also come into place. That also happens. So that's basically something that if you take it in an enterprise setting. Now in enterprise setting, it is goes a little even beyond. Is that I may say, as a CEO, right, to my digital CBO, that I want to reduce losses by 10%. And this is something that is a goal based orchestration. It's like I'm saying, this is the goal that you have to achieve, right? And that basically, I don't care how you achieve it. This is what I will give it to my digital CBO kind of stuff, right? Now digital CBO has to then think, okay, goes to accounts department, say, okay, fetch the data from accounts department and say that, okay, what are the what are the top cost items, for example, right? Where is the slack? Where can I cut kind of stuff? And they may say that, okay, marketing, is the biggest cost. So then the digital CV will go to marketing and say, okay, what are these required? These things kind of stuff. Has it created impact in last, few years, whatever marketing you're doing, kind of stuff. Then it might also go to HR and think about, whether this team, that team has some slack on those kind of stuff and can be reduced. It becomes a very, very complex goal based, and it might a multi-step, right? It might include, you know, uh, some kind of task created. Then we might realize that, okay, the cost actually has not reduced, so because there's also a P&L impact, those kind of stuff. So there's a lot of loops and those kind of stuff. So it's a very, very complex problem kind of stuff, right? So that's basically, again, is but the goal base is, it's not really a single event, multitask kind of stuff. It is a goal base. So the pivoting from like a single task to something which requires multiple tasks, to something which is completely more at a very high level of plane, is the goal based kind of stuff, which is actually extremely, extremely complex kind of stuff. Now that's something that you can imagine, that how, you know these kind of thing. Now start to imagine that if I have enterprise, agentic enterprise, something where, and this is basically an extreme example, that there's only a single human founder, and he's saying that I am actually created a unicorn company, but I have zero human employee. Now that, so what kind of architecture is, agentic, architecture this enterprise might have, is it might have everything digital, like your chief marketing agent to your chief sales agent to chief operations agent, chief finance agent. Everything is completely agentic. These are AI agents. And then, they might have team which again have, these kind of agents kind of stuff. So so imagine if the future enterprises are these kind of agentic enterprises where, there might be very few humans and those kind of stuff. There's this requires a very different kind of thinking. It requires a different planning. It requires very different kind of infrastructure, and a lot of training and a lot of understanding of how these agents will work and stuff, right? Now I've talked about, I've taken you through in some ways real life examples, and sort of given you a glimpse of how future agentic enterprises will be, right? Fundamentally, then, let's break down, given that multitask, goal based, and single task, those kind of things that may happen in enterprises also. What kind of agent? What would an agent have, kind of stuff, right? Now, so first thing is that if I have to talk to Butler, right, and if there's a digital CBO, the first thing is communication. Right? I should be able to talk to someone in my natural language. Right? I'm talking to someone in natural language. So AI agents should be language equipped, which means they should be able to understand language. The good part about AI agents, because they are digital in nature, they can understand any language. Right? So you could be speaking in Tamil, you could speak in Telugu, you could be speaking in Hindi, English, whatever, Russian. They understand language. That's basically is one fundamental part which I wanted to highlight, is the communication part, which basically also humans have, is that they use senses to basically hear, listen, and understand the language kind of stuff. So communication is something that is fundamental here. As we go further, is the intent detection. Now, every agent needs to detect. So if a query has come, if someone has asked something, what is this person trying to ask, right? So the intent detection is also something very fundamental to any AI agent that you will find, any framework that you look at, is that there'll be some kind of intent detection, right? What is the fundamental intent? Is this the intent around, cooking? For example, I might have said, cook me a dinner, right? So intent is cook, right? If I'm saying, okay, shop for me, Nike shoes, because I want to run marathon tomorrow, kind of stuff, right? So shopping is an intent. So it's intents detection is so fundamental in any AI agent. So that is also one thing that you will find common if you're looking at AI agents. And then the orchestration part. Now, every agent will not have orchestration. There will be orchestrator agents which which might be fundamentally might have more power compared to more simple agents that we have seen. Like for butler would have a lot more orchestration power needed than compared to what a cook might need, kind of stuff, right? So orchestration is also something very fundamental in AI agents, which means that if I'm getting something, how am I orchestrating, right? How am I controlling? The orchestra is something that, orchestrator says, okay, now you play this music, now you play violin, now you play this, now you play that kind of stuff, and can create a music out of it, kind of stuff, right? Um, Similarly, orchestration means here is I've gotten a task. How do I orchestrate? How do I tell you do this, you do this, you do this, and those kind of stuff, right? So orchestration is also very fundamental to building an AI agent, and that also is something as we go further, go detail into what we are building in AI agents. It's something that I will also highlight orchestration part, right? Then reasoning and planning, right? Once you've gotten the communication, you have detected the intent, now you're orchestrating, now you've given to something, how do you control, so how do you give to whom to what, and even when you're given it to a particular agent, that person might be thinking, how do I do it, kind of stuff. So reasoning and planning is also something that you would see in an AI agent, where an agent might have to plan. Plan means that I have been given a goal, or I have given a task. How do I break into many tasks? How do I say this will happen, then this will happen, then this will happen, then this will happen, right? For example, I might be saying plan a trip, my trip to Greece, right? That's something that I've told my agent, my AI agent, just plan my trip to Greece, and I'm planning to go in December this year. So plan it. And so then our customer will say, okay, I need to see December, so I will need to look at flights, I need to look at hotel, I need to look at what kind of places Manoj will like, and Manoj does not like museums, so I will skip museums. Manoj does not like this kind of hotel, so I'll skip this hotel. you know this is the kind of budget that I Manoj usually have for. So good part is the orchestrator knows my personal preferences. That's also one thing which I'll highlight here is memory. Is in every agent you will see a concept of memory, and a short memory and a long memory, which means that what is short memory is what is memory which I want to store for a particular short amount of time, and the memory which basically I want to store for a longer time, kind of stuff, right? So my preferences will be in my long memory, right? The agent will store that for a very long time because my preferences usually will not change, kind of stuff, right? And so basically that is also something I want to highlight here, the concept of memory, which is you'll find in every agent architecture out there. And then and then finally basically you have this task action and completion, which might require an agent to reach out to external tools, which might be external apps like booking.com or Uber and those kind of stuff. An agentic architecture, we call that as a tooling layer. So tooling is an action, and completion is also something that you will see as part of tool access, and all those things also part of a lot of AI agent framework. Another very, very interesting thing which is needed, because AI agents are autonomous, they self-correct, they learn, right? Which means the concept of reflection, right? Which means that every AI agent will, when they say that I have completed this task, they will also reflect whether this task was, of high quality or low quality. Now that reflection might come based on the input. Like I said, here is something I booked for you, an Uber. I said, I might have said, oh no, that was very high, I don't like this, let's say high priced Uber. I like low price car, shorter car, not a bigger car, kind of stuff. So that goes into the memory of then the agent, and then the agent will reflect, and then next time when I say book me an Uber, because of the reflection, which where the correction happened in AI agent, the next time the agent will not book a bigger car for me while booking a Uber kind of stuff, right? So these are the very, very high level concepts in AI agents, and that basically and I want you to you know spend like, if you have to spend like 1 minute looking at this, because when I'm going to talk about agents, all these things will come out, and I want you to connect the dots here, which I'm putting here when I'm showing how a real when we build an AI agent, how will that connect kind of stuff, right? So communication, intent detection, orchestration, reasoning and planning, task completion, right? Action completion, the concept of memory, and the concept of reflection. Any questions anyone has till now, while I pause here for like 30 seconds? Yeah. So basically, those are the things that I thought I'll highlight here. Now I have also, you might have noticed that I have put some Hindi words in some ways, but basically that I wanted to connect, and this is comes from Veda, Indian Vedas, that our mind, basically our brain is composed of manas, which is mind or man, buddhi, chittam and ahankara, right? Basically, these are four components that you can think of, when you look at your when you look at humans kind of stuff, like human brain and those kind of stuff, right? So first thing is that orchestration and all those things, right? I might have said, I might get some kind of task, and I might say uh, whom to give, whether I should do or not. I don't like doing this and those kinds of stuff, right? So I'm doing a lot of this in my mind, sort of man, and my mind is playing something, right? Which basically the front, every whenever we get a task, this is the first thing that goes into us is the mind, because it comes from the sensory inputs and then hits the mind kind of. So that basically is where the intent detection, orchestration, some bit of orchestration that is happening kind of stuff. And reasoning planning basically is where is where the buddhi starts to get into, where you with the logic kind of stuff, your brain start to think, how will I do it, those kind of stuff, right? So from senses, which is communication, right, to man, which will basically where the intent detection and a lot of initial, you can say, actions, and how do you do it kind of stuff. Then the logic goes into it, and the chittam, which basically is the memory part, which basically where the brain stores or kind of stuff, is basically is interesting that if you look at it, how Indian Vedas described human brain, is how in some ways AI agents can also be broken down as we're building. And this is not something that I got visible, as we started building it, and suddenly we start thinking, okay, this is this, okay, this is. So we are sort of, you know uh, you can say that replicating what a human brain looks like kind of stuff, when it comes to AI agents kind of stuff, right? So that's basically is sort of a very broad, I would say, overview of how, or what AI agents are, right? They are autonomous. They take inputs, they take tasks, and then they complete tasks, and then they complete tasks based on a lot of internal engine, which basically hovers around reflection, reasoning, memory, communication, a lot of things, right? So first thing that we noticed here is the communication part, right? So when we were designing our agents, and this is where fundamentally we have spent a lot of time is creating a communication protocol, right? Because agents need to talk to each other in in natural language. That basically is the power of agents. I could talk to any agent in any language. That's basically the power which comes from the LLM part, right? Because every agent, because they are AI enabled, they have the power of language. They have the power to take input and communicate and speak in the language of any language, and they still will be able to understand kind of stuff. So the power of communicating in natural language is something that we first addressed by creating this protocol, which is we call agent text transfer protocol. It's ATTP for short kind of stuff. And it's an interesting thing that we developed, and we wrote a paper also, a research paper of course, not just on this, but it broadly on agent networks. Is which on in that paper we also described ATTP protocol is fundamentally creating sort of an API-less integration between agents, right? If I am as a employee, let's imagine as a new employee, go into an office, right? How am I introduced, right? I will say I'm from tech department, right? I can write Python code. That's basically how I get introduced, right? And then I start talking to my coworkers, my boss, and then I'm assigned tasks. But everything is happening, the discovery to broadcasting to task assignment to task completion, everything, all the communication happening in local language. I don't need to API integrate with other people, right? As a humans, if we meet, we don't say, okay, let me API integrate with you. Let me create an API. What is your API? What is my API? We don't do that, right? We start talking. We start to understand each other. So ATTP is that basically agent text transfer protocol is basically we realize that if new AI agents get introduced into the enterprise, they need not be they don't need to be custom integrated. They should just be able to start working with each other, very very quickly kind of stuff, right? So that basically is the reason why we created ATTP. ATTP fundamentally has a slash, basically talks in query text. So you basically say, let's say for example, in this example here, there are two agents here, support agent and order status agent, right? So the customer goes to the support agent and says, my order ID da 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 is not delivered. Support agent will say, okay, for this intent, right, I have to go to the there's some kind of orchestration. Okay, so for this intent is order status, so I will go to the agent kind of stuff. And the order agent will say, it might just say, it may not say like that, but can say like as a human, sir, I need to know the status of order ID 1, 2, 3, right? So it's saying in a very natural language, and and the order status may reply in a very natural language, order status delivered hai, right? Has like a Hindi word. So order status is Hindi word, or you can speak in Kannada. It doesn't matter which language speaks back. The good part is the agents are sort of you can say language neutral. From that perspective, is that they can translate and they can understand any language kind of stuff, right? They can detect the language, what language you're speaking, and then they can execute kind of stuff. So 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 this basically, if you look at it, it is not like I'm doing an API call where I'm saying order ID colon this, right? And I don't need to understand what is the API or the side, because I'm just sharing in the query text kind of stuff, right? And that basically is fundamentally the HTTP protocol is. Of course, it is not just query text that we have. We have also a response text in that protocol. We also have intent, entities, and metadata, and these are primarily designed so that it helps the agent to not hallucinate. So there is a concept of intent, entity, the metadata has been put. It is not like there isn't any, and it's just only query text. But fundamentally, if the agents are talking as if they're talking in natural language. And the other thing is that each agent has a readme endpoint, which means that you can ask the other agent, how should I interact with you, right? What maybe what do you do, what is, so it's like, how do I introduce myself, right? The same thing is the readme endpoint, that every agent in what we in Groclake has a slash query and slash readme by default, right? So you don't need to say, okay, which endpoint to reach to this agent is always slash query. And to understand the agent, what that agent is always readme, right? So these two you can use to understand each other. I don't know if all of you are able to follow me till now. If you have any question, feel free to ask. I'll be happy to answer it, kind of stuff. Now, so that basically, yeah, Krishna. I'll just quickly, one sec. Krishna, I think we see terms like AI agent, multi-agent, agentic AI, agentic rack. How do we define this? Okay. So basically, AI agent is something that I've just said is basically agent which takes input and then take a task and then does a task. Multi-agent is something, again, I told you in a sort of example, that the butler example that I gave is actually a multi-agent architecture where there are multiple agents working together to do a thing. It's not a single agent, right? It is not a single agent which is working with you. It is multiple agents are working together in a collaborative manner, like you do in office, right? You collaborate together to get a task done. It's like same thing. It's a multi agentic AI is basically an AI where agents are there. So it is nothing different between what and a lot of the concepts that I'm telling you here: reflection, reasoning, task planning, tool calling, tooling layer, and those kind of stuff is part of agentic AI framework in some ways, kind of stuff. And agentic RAG is basically is nothing but where the some kind of RAG, basically where some kind of database, some kind of knowledge base is attached while we are talking to that agent, right? But if you ask me, RAG is like I mean, if like for example here support agent, right? The support agent uh, uh, for a query like what is the refund policy, right, of your company, it needs to access a knowledge base, right? And that basically is where the RAG comes into picture. So I would not really say what is agentic RAG in some ways. If you are talking about AI agents in general, the data part, the data sourcing part, data access part, which is basically where the RAG part, the retrieval part, rather, RAG is retrieval augmented generation, right? The retrieval part, which basically is retrieving from a knowledge base, is basically where you can say it is agentic RAG, but I think there are a lot of terms which are floating around, but they are sort of overlapping kind of stuff, right? So now, another question: if you use agent frameworks, the communication between agents are probably abstracted. In that context, what is this ATTP? The Okay, the communication between agents are probably abstracted. I probably don't understand this question, Krishna. If let me see if I can mute you. Yeah, can you maybe you want to ask talk
Yeah.
to? Yeah.
So am I audible now?
Yes, Krishna, you are. Yes.
See, my question is if I use frameworks like, say, Crew AI or AutoGen,
Yes.
any other frameworks,
Yes.
don't have to explicitly handle this communication between these agents. That is more of in the constructs of that agents, right? Probably I can say in what sequence the agents need to execute. So what are their role? What is the task? All those things can be defined in a certain construct. Okay. So we don't have to handle this communication that is happening behind the scenes, right? So in that
Yes.
context, what is the need for this ATTP, right? Anyway, probably you may be explaining that later, and I'm just trying to
No, no,
understand.
I'll
Yeah,
yeah. No, no, I understand your question. So basically, let's take Crew AI, right? In Crew AI, you might say that, these are the tasks that
right,
I have, right? And these are the task descriptions, right? For these task descriptions, these are the tools, kind of stuff, right?
right,
Now, but you still to connect with the tool, right? You will still need to define, you need to still need to convert that into a particular kind of API kind of stuff, right? Let's take a simple example. I think you might have seen that also, the weather example, right? Right. What is the weather in, let's say, Bangalore? Is something that is a question which is asked, right? So the task is to find the weather in Bangalore. Now for that, the external tool calling will happen with where the API call will happen, kind
Right.
of stuff, right? So that is a very simple example for which you don't need uh, this the you can say that I don't need this kind of HTTP protocol, right? Imagine where an agent, see here, in the example, which a lot of crew AI frameworks, and that's where the limitation of these frameworks are, at least in the enterprise workflows, I can say that, is that agents need to talk to each other collaboratively to complete a task. That basically is fundamentally how you would also see humans do that. If they're given a task in the office, they work together to complete. It's not just a simple that, find me a weather, and then goes and finds the weather kind of stuff, right? It's so that basically is one thing, is that there you're just picking a tool and then getting the output and giving it to the, in a human friendly response, you're giving it to the to the wherever the query has come to the customer kind of stuff. So it's a very simple, interaction. You choose a tool and then you get the response, and then you give it to the person.
Right.
That's not, for that basically you don't need a HTTP. You're right.
Mhm.
Why create this complication? But
Right.
where the one agent, that you give it the task to one agent, the other agent needs to talk to another agent,
Mhm.
is where the communication layer starts to come into picture. And that's where the HTTP becomes very interesting kind of stuff. Right?
Okay.
I don't know if I am able to answer that
Yeah, I
very
got
clearly.
that. I think probably this is more in a enterprise kind of context.
Yes,
Because all
yes,
the
yes.
examples that we find, right, I think they don't think from an enterprise perspective. I think probably when
Yeah,
there
yeah.
are.
That's basically where our solution is, right? We are not. So if you have to create very simple, if you have to do very simple tool calling, right?
Mhm.
You don't need a. I mean, you can do it in Groclake, but
Right.
you don't need HTTP kind of protocols for that. You don't need that kind of stuff. And I'll get into more detailed architecture of what we are doing kind of stuff. But when you look at Groclake, you have to look at enterprises. You look at workflow automation. Then you have to look at collaboration. These are
Mhm.
the three things that you will look at. And the reason why we were doing this is collaboration in agents is one of the most talked about. If you when you go to enterprise, agentic, enterprises kind of domain, is one of the most important layer everyone's talking about. And that's where, we thought, let's do that, build this kind of framework. Any other question from anyone? Okay, so now let me quickly, I think I might have only 10 minutes here. So one thing is basically, we, one sec. Yeah. So this basically is HTTP protocol, is something that I thought I'll talk about here. And not only so now in agent, every agent that we have a HTTP adapter, which basically means that the agent can now talk to the external world. HTTP adapter basically gives that power or capability to the agent, that it allows it to communicate. It makes the communication easier kind of stuff, right? But also HTTP adapter also makes sure that authentication and encryption happens on all the communication which is happening, which is so critical in enterprise world, that if you go to any enterprise, they'll say security is something that is the top of my head kind of stuff. I don't want my agent, because I might have a lot of agents. I don't know what my agents are doing. I want to make sure that Anything that agent is doing is of course encrypted, authenticated, and also some kind of guardrails should be there so that these agents are not talking to some random party and giving my data kind of stuff, right? So that's where the lot of security features are there in HTTP adapter to ensure that it is giving data to anyone who is authenticated and not to anyone who is not authenticated, and those kind of stuff. And of course, HTTP adapter has some kind of orchestration feature where it detects the intent and it basically then calls the tool one, tool two, tool three, and that basically is something that also ADTP adapter can do. So one concept is two, three things I want to highlight is concept of ADTP, which is unique to Groclake, but I'm quite sure a lot of other people would also build something like that or use ATTP for communication. And the adapter, which basically is sort of makes any agent that you build ATTP compliant and those kind of stuff with authentication encryption. Yeah. Now, so that basically, so little bit on the HTTP protocol is that, I talked about, the query, right? The query comes to me that, sir, I need to know the status of order ID. Of course, this query itself is enough for the agent to understand what it needs to do, but some kind of helper data, like you can say, that can also be provided by the other party, so that there's lesser hallucination and there's lesser thinking load on the other agent kind of stuff. So which means that the intent can also be provided by the support agent in this case, that the intent is order status, which means that, so which actually makes the life of the order status agent to understand, okay, this is order status. And some kind of entities can also provide it, like order ID is this and user ID is this kind of stuff, right? So it basically has query text, intent, entities, and metadata. These are the four things on which the whole protocol works. Query text is mandatory. Intent, entities, and metadata are not mandatory, so they can be just not be there if you want it. Keep it simple kind of stuff, right? Now, I've talked about agents, AI agents. I've talked about the HTTP protocol. How it's useful for communication part. Here's something that I thought I'll focus on the base agent. Now we have a base agent class. It may be a little bit more technical in nature here after this, so bear with me. But I'll try to make it simpler. So we have basically a Grok agent, which is a base human a base class, right? Is a base agent on which you can extend and create any agent kind of stuff, right? And this base agent has some basic things, like it can basically take it has orchestrator built in, it has basically intent detection built in, it has some kind of some kind of pre-built capabilities like summarization, like sentiment analysis, like chatbot for world knowledge. The Grok agent already has, so you don't really need to build. If you're just building these kind of simple agents, you can just use the internal capabilities of the Grok agent, right? You can think of, for example, Grok agent as like a human, right? Human as a class, and then Manoj Gupta is a human, so the Manoj Gupta then extends that human capabilities and then builds his own capability on top of it. And let's say, Monica is another person. She basically also is part of it, takes the human base, class, and then builds on top of her own capabilities kind of stuff, right? So Rock agent is that human class, you can say that, on which basically any agent can build on top of it and extend and build more capabilities beside the base capabilities of the agent kind of stuff, right? So Grok agent is one other concept here apart from HTTP. The Grok agent is something that we provide to so that enterprises can build their custom agents very, very quickly using the base agent. And it has basically built-in HTTP adapter, it has built-in orchestrator, it built-in intent detection, intent handlers, and those kind of stuff, right? So that's something I thought I'll just uh, spend some time on. Uh, Now, just extending this, right? So extending the whole, you know, agent to enterprise setting. This is how some kind of flows might happen. Now, what I'm showing here is a few more things like agent private cloud, right? It's basically like a private cloud where agents are there. It's like departments in an office enterprise, right? So there's accounting department and there's the HR department, and then there is marketing department and those kind of stuff, right? So APCs are like that. These are private clouds in an enterprise, because you don't want your accounting team to share data with HR team, or HR team to share the salary data with marketing team and those kinds of, right? So you want some kind of guardrails that only accounting team knows what is happening in accounts kind of stuff, and HR team knows what is in HR kind of stuff. So this that concept is there, which is agent private cloud. And then if I have to talk to anyone in the accounts department, I'll probably talk through the manager of accounts, right? So there we have a concept of gateway agents, which basically are the only agents which are allowed to talk to the external world, and they basically then communicate internally for any data kind of stuff. All these we are doing because we want to make sure the agents are sharing data in a secure way, and then not sharing data which is they're not supposed to share outside. And so the security is so fundamentally ingrained in architecture from that perspective. And then we have concepts of around agent name servers, which basically is that if any new agent comes, it basically get registered in the agent registry, and then gets become discoverable through agent name server, because in agent name server you have your capabilities, agent capabilities disclosed, so that if someone needs to know who is the best person for accounts for this answer, they can go to agent name server and look, okay, this is the agent which is good, let me talk to this agent kind of stuff. So discovery of agent is something that is also a part of what we're building through in this kind of stuff, right? So that basically is about the architecture broadly, and then we have created this whole framework for enterprise agents. It basically allows you to, it's like you can imagine a factory kind of setting, right, where supply chain and machinery, which allows you to create manufacture agents, and then deployment and monitoring happens. So this we have multiple components here which we are building, and we are built for to make sure that we can give enterprises this kind of stuff. Now, there's ton of other stuffs here. There's Groclake, which basically is again, something that we provide as a support for enterprises so that they can store their catalog. Agent Lake is the agent, a lake of agents or a repository of agents. Data Lake is how you access data, because data is so critical in the whole enterprise agentic AI workflows that you should be able to access data, structured and unstructured, from any source kind of stuff, right? So MySQL data to Elasticsearch to vector databases to snowflakes, anywhere you data have, you should be able to access it. PDF, CSV, document, buckets, S3 buckets, whatever your data is, data lake gives you access so that you can access those. Vector lake is so specific to AI, because vector databases and vectors are so fundamental to whatever we do, whether we do semantic search and those kinds of stuff. Vector lake is that. A model lake is basically a lake of models where you can choose which model to choose, and then use those models. In future, we will also support your custom fine-tuned models in model lake, so you can put that and host it and do some kind of inferencing there. And ONDC Lake is unique to us because we are the largest technology provider in ONDC. So we provide you a gateway to ONDC also through our infrastructure kind of stuff. Uh, Yeah, I think a lot of other stuff is there, but I'll take a break here and take few questions. Let me just see if the questions here. Q&A. Okay. One sec. So are we going to cover how someone can build these agents? Yeah. So basically is the plan with you only 7 minutes now. So let me see what can I do here. The idea was to show how you can build agents on your platform, on our platform. Does the data ever leave the boundaries? Example, Chatbot, does it use OpenAI kind of partner? Yeah, so data basically through data lake, the data is where the data is at the source kind of stuff, right? And data is accessed only for answering task completion, those kind of stuff. So data at rest is with the party. Data doesn't we don't store any data at all kind of stuff. Now the state some data is stored in the memory lake because that's a memory which of the agent that might have some data related to customer or those kind of stuff. But what we're trying to do is sort of PII mask those data. That also is a work in progress for us. Uh, so uh, so there's another question. My question is, can we create an Ignite which places order on behalf of customer from various seller apps like Blinkit, Zepto? How can it be created? How do we implement seller APIs? Is it possible? Yeah, basically you can. So in agentic world is not like you cannot do what you are doing kind of stuff. The good part of agentic AI is you can put an agentic layer around whatever you're doing and make everything agentic, which basically means that I should be able to talk and converse and use voice and multilingual capabilities to just communicate and ask my agent to do whatever I'm to do. But in the back end, basically all the APIs integration may still be there kind of stuff. So you can through basically if you're looking specifically to understand the seller app APIs, then basically you can use ONDC Lake in our infrastructure to access that. So what I'm trying to highlight is that it is not like you cannot do things. You can do whatever you're doing, but now you're doing it more in a more natural with the language kind of support and with interfaces which are different kind of stuff and more automation. A lot of things can get done without you really need to tinker and say for this if and else logic. You don't need a lot of if and else logic. That basically goes away kind of stuff, right? What was the human in the loop in the implementation? So human in the loop is something that we have not yet designed, unfortunately, and that's something is we are working on. So we will come back on the human in the loop, uh, at least in the enterprise setting, is something that we are still thinking about. Please conduct another webinar which is how to build and deploy agents for enterprises. Okay, so I will do that. I think I just underestimated how much time it will take to go through the whole concepts. Now I think we have covered a lot of concepts. Uh, I can probably next time just we will just focus on the how to build an AI agent using Grok agent and ATTP kind of stuff. What it takes to customize Grok agent to perform a specific task, let us say product owner agent in a product development. So basically it is so a lot of the heavy lifting of an agentic AI has been done by us, right? Which means that communication layer is taken care by us, right? Intent detection, intent you can say security, authentication, encryption, discovery of agents. A lot of heavy lifting is done by us kind of stuff. For you, if you're building a custom agent, the only thing that you have to really change is the handlers, the intent handlers. And that basically also is something that we basically have taken a lot of learnings of building an AI agent and stuff. So you have to do very specific thing in the intent handler that this is what I want to do, and and a lot of other things are taken care by us kind of stuff. So that's the beauty of whatever I presented, is that it makes building custom agents very simple. uh Let me go to what is the business process this network of agents successfully deployed. Sorry, I'm not able to understand what is the business process this network of agents successfully deployed. I don't know if you're looking at monitoring of these agents once they're deployed, or looking at how these agents are deployed, right? So if you're looking at how these agents are deployed, basically these agents are deployed, as you know, these agents are deployed in a way that each agent can have multiple copies, right? So one thing that we realize is for scalability, it is not that I only should have one agent, right? I can have, at least in the world of AI agents, I can have multiple of Manoj Guptas, right? And then these multiple of Manoj Guptas can be doing webinars to multiple of topics and those kind of stuff, right? So you in deployment is basically, and this also Satya from Microsoft CEO said, is that every agent is a combination of a lot of things, but Kubernetes containerized service is actually part of almost every agent architecture, right? So we're also using something similar to that for deployment, is Kubernetes, so that multiple pods can be deployed, and those kind of stuff, right? uh, uh, can you throw light on part whether both agent lake and ATTP modify the agent registry simultaneously, or how exactly those components play their respective roles? Like conflicting updates can lead to corrupt data. Single shared agent registry may bottleneck on scaling up more agents, or did I understand? So basically, the agent registry, see, ATTP doesn't modify the agent registry. ATTP is just a communication protocol, right? Agent registry is maintained by an admin agent, right? Now, you may, as an agent, you can register the agent in the registry, but someone is to say, okay, this agent actually is qualified to be part of the agent registry. So there's of course an approval process, with some other agent can do it, and say that now this is in pending, and now it is confirmed, confirmed in the registry kind of stuff. So there's only one person who is basically uh, is approving kind of stuff. Now you can, of course, every agent. Now, other thing which I probably did not highlight is every agent has a UUID, right? It is like, you can say that, it is like an ID, unique ID given to the agent, that this is the ID, right? And so if so once you register in an agent registry, you are given an ID, that this is your ID, this is the ID in the registry, this is a unique user ID kind of stuff, right? And that basically becomes the way, that's basically becomes part of the registry, and everyone can know that this agent is this part of the registry. Now it may happen that I have registered twice, right? Now that is something also, is where, it is something that we are working on. How do you know that this agent is same, and I registered twice, right? If the name might be different, so in which is case, do you just make two agents live with similar capabilities in the network? Probably not, right? You probably want like one agent for specific capability, rather than two agents with two different names but same capability kind of stuff, right? So this is something to think about. But yeah, it's the agent registry is definitely something which is well protected from that perspective. Uh, so so I think the other questions, given the interest of time, I'll skip those. But I realize that we have not been able to cover the next part of the session, which is, I wanted to show a live demo of creating an agent and deploying it, and telling you how you can build a agent very quickly kind of stuff. So I'll take that as a rain check, and come back with another webinar just specifically on creating the agent, and we'll skip the whole introduction part in that one. So sorry about that. Yeah, with that, I think we'll wrap up. And this recording will be available on YouTube. Give us like a couple of days, and we'll let you know. And hopefully you liked it, and have a great weekend. Thank you. Bye bye.